We've literally all been there. You spend hours, maybe even days, writing this absolutely perfect web scraper. You set it to run overnight, you wake up, pour a coffee, expecting this beautiful clean data set, and boom, your console is just screaming red with HTTP errors. It's incredibly frustrating to find your script stop dead in its tracks with absolutely zero data to show for it. But hey, don't panic. Welcome to This Explainer. I'm your guide, and today we're going to diagnose and actually cure these specific scraping headaches once and for all.
Okay, so let's quickly hit the roadmap for today. We're going to look at exactly why your scrapers are failing in the first place, and then we'll tackle fixing the dreaded 403 forbidden error. After that, we'll handle 502 bad gateways, resolve those tricky 521 and 522 connection issues, unpack the 499 error, and finally, we'll wrap up with some much smarter scraping best practices to keep you up and running.
All right, let's jump right into Section 1, why your scrapers fail in the first place.
You know, it's absolutely crucial to realize right out of the gate that HTTP errors, they aren't random glitches. They aren't bugs in the matrix or just bad luck. They are highly predictable responses to specific behaviors. So we really got to ask, why do scrapers constantly break? What is it about automated data collection that makes target servers get so incredibly defensive?
Well, it basically all comes down to the stark contrast between human behavior and bot behavior. Think about how you actually browse the web. You load pages kind of slowly, you use a real browser that holds on to cookies and history, and you're coming from a trusted home or office IP. But a scraper? It's firing off rapid-fire requests. It's often using a recognized scripting library instead of Chrome or Safari. It reuses the exact same IP over and over, and it has zero natural human timing. The server spots that unnatural behavior, and boom, it immediately triggers its anti-bot defenses.
And that brings us to Section 2. Fixing 403 forbidden errors.
If the internet had a strict, unyielding bouncer at the door, the 403 status code would absolutely be it. A 403 forbidden essentially means the server totally understands your request, like it knows exactly what you want, but it is actively, stubbornly refusing to authorize it. I really want to stress this point. A 403 is almost never a bug in your actual code. It is an intentional, deliberate block by that target server.
So, what exactly sets off this bouncer? Let's look at the usual suspects. Typically, your IP's been flagged because you're sending too many requests, hitting those rate limits. Or maybe you're missing crucial context, like session cookies or realistic headers. I mean, if your user agent header screams Python requests library instead of, say, Google Chrome, you are instantly giving away that you're a bot. And the more sophisticated systems out there, like Cloudflare or setups using TCP/IP fingerprinting, they're going to spot that in a millisecond and drop the 403 hammer.
But don't worry, there's totally a cure for this, and as your guide, here's your exact prescription. First off, you've got to add realistic headers. Make absolutely sure your user agent and accept parameters match a real modern web browser. Second, implement proper session handling and pass cookies, just like a real user session naturally would. Third, you got to pace yourself. Dial back that request frequency so you aren't tripping rate limits. And finally, rotate your IP addresses, ideally using residential proxies so your traffic genuinely blends in with everyday home users.
All right, moving right along to Section 3, handling 502 bad gateway errors. Let's see how this builds, because now we're shifting from intentional security blocks to actual infrastructure struggles. A 502 bad gateway basically tells us that one server, somewhere on the internet, got an invalid response from another server, usually the upstream target server you're trying to scrape. Unlike that 403 bouncer we just talked about, a 502 is usually a temporary infrastructure hiccup. The server is, quite literally, buckling under pressure.
So why does this happen when you're scraping? Well, often the target server is just overloaded, or maybe its back-end services are crashing. But here's the really fascinating kicker. Sometimes, your scraper is actually the one causing the problem. If you're being way too aggressive with your concurrent requests, your script can physically overwhelm their server, causing it to fail and throw that exact 502 error right back in your face.
The fix here really boils down to one word: patience. Your very first step is to retry the requests, but you need to use an exponential back-off strategy. That just means you wait progressively longer between each successive retry. Give it a minute. You also critically need to reduce your concurrent requests. Please don't blast the server with 100 connections at the exact same time. Add some deliberate time delays and distribute your requests so you aren't hammering a struggling server from just one single point.
Next up, Section 4. Let's resolve those 521 and 522 connection errors.
These are two related, but honestly, very distinct server-side connection errors that pop up all the time when scraping. A 521 error means the origin server is actively refusing the connection. It's a hard refusal, very often a firewall or a service like Cloudflare just completely shutting you out. The immediate fix there is to switch your IP address, maybe hop over to a residential or mobile proxy. On the flip side, a 522 error is a connection timed out. The server isn't necessarily blocking you on purpose, it's just completely overwhelmed and sweating bullets trying to keep up with your requests. To fix a 522, you just need to bump up your timeout settings and slow down your request rate. Give the poor server a fighting chance to actually process what you're asking for.
All right, let's look at Section 5, Understanding the 499 error. Okay, we are completely flipped the script here. Up until now, we've basically talked about the server throwing its hands up. But with a 499 error, it's a completely client-side bailout. A 499 literally means client closed request. In simple terms, your scraper closed the connection before the server could even manage to send a response back. If your scraper were a human being, this is the exact equivalent of being insanely impatient and just hanging up the phone before the person on the other hand can even say hello.
Because of this, it's pretty much a self-inflicted wound. The absolute most common trigger is just that your client timeout setting is way too short. But it can also happen if the target's requests legitimately just take a long time to process, or if you've got some network instability on your end. It also pops up if you're running incredibly high concurrency without handling your resources properly. Your local system basically gets bogged down and just drops the connection so it can move on to the next task. Thankfully, fixing this is beautifully straightforward. You literally just need to teach your scraper to wait just a little bit longer. Step 1, bump up those client timeout limits. Give it some breathing room. Step 2, optimize your overall scraping speed and efficiency. Step 3, limit those concurrent requests so your own local machine and network aren't creating a huge bottleneck. And finally, just double-check that your own network and proxy connections are rock solid and stable.
And that brings us to our final stop, Section 6, Smarter Scraping Best Practices.
Look, knowing how to fix these errors individually is great, but architecting your scraper so it prevents them entirely, that's so much better. The absolute crucial point here is understanding exactly how the server views your connection based on your IP. Think about proxy trust levels. Data center proxies, they're super fast, but they are incredibly easy to detect and block. Residential proxies are a lot harder to spot because they route through actual home internet connections, making you look exactly like a regular person. And mobile proxies, they have the absolute highest trust level of all, utilizing 3G, 4G, and 5G networks. Choosing the right type of IP fundamentally alters how a target server treats your request from the very first handshake. Combine that knowledge with what I like to call the universal cure for resilient scraping. To make your script truly act like a human being, you absolutely have to implement smart IP rotation. That's going to prevent those bans and throttling. You've also got to add request randomization. Inject some random delays, consistently rotate your headers, manage those sessions naturally. And finally, you must strictly control your concurrency so you can find that perfect sweet spot between data gathering speed and network stability.
If you take literally nothing else away from this explainer today, please let it be this core mantra. Better infrastructure, smarter requests, and proper IP management. That right there is the absolute ultimate formula for building truly resilient scrapers that just don't break.
So, I'm going to leave you with a final, slightly provocative thought to consider the next time you sit down to write some code. Are you just patching errors as they randomly pop up, or are you actually building your scraper to behave like a real human from the very start? It might be time to rethink your architecture, apply these concepts to your own code, stop waking up to broken scripts, and start gathering your data flawlessly. Thanks so much for learning with me today, and hey, happy scraping!